This is low frequency, a wobble. 8 hertz. 10 hertz, it rises up and hits the plate. 12 hertz. And then at 13 hertz, it turns completely flat, like a spinning top at its apex. We turn on the power. First it wobbles, 10 hertz, and then it rises up at about 12 hertz, and then it turns into a flat spin. Slow it down a little, and it wobbles, 12 hertz. Speed it up again, turns into a flat spin at 15 hertz. Pretty cool, isn't it? A lot of power there. Here we have 2 sets of 3-phase wire coils, which are staggered and both turn clockwise. And in the center we've put a magnetic flywheel with 8 magnets. It's about 80 millimeters outside and 25 millimeter hole, and sitting on a 12 millimeter rod. Now for these particular dimensions, if we add 3-phase power, it'll start spinning, and then at about 9 hertz it'll wobble, and then it'll rise up by about 12 hertz, and then by 15 hertz it'll go to a flat spin motion. If we slow it down again to about 10 hertz, it'll wobble. Speed it up again, it'll go to a flat spin motion. So there's a transition between these two forms, wobbling and flat spin. If we go to higher power, it'll stay as flat spin. 20 hertz, 30 hertz. Slow it down. Now this particular form of transition gives an upward force which might be related to UFO propulsion. We can see a very similar result with these two sets of three-phase coils and a magnetic flywheel with just 4 magnets, 25 millimeter hole, sitting on a 12 millimeter rod. We started spinning with three-phase power. 10 hertz it goes through a wobble phase. By 11 hertz it rises up, still wobbling. By 14 hertz it transits to a flat spin phase. Then we get a transition back to a wobble at lower power. Turn up the hertz again, goes to flat spin. It'll stay at flat spin as we increase the power. So this transition between two forms of spinning creates an upward force that may be related to UFO propulsion. If we make the hole in that magnetic flywheel a little bit larger, say 30 rather than 25 millimeters, now the wobble phase becomes a little unstable. Yet when we go up to 13 hertz, the flat spin phase is still stable. Now if we go down to a slightly smaller hole, say with 4 magnets, 20 millimeters rather than 25 or 30, we get a very stable wobble phase. Say at 10 hertz, and it'll rise up. As we go higher, there's no flat spin phase. Now for these 4 magnets on a flywheel and a 20 millimeter hole, we saw a 12 millimeter rod only gave a wobble phase, but I've gone down to an 8 millimeter rod to see if that changes the behavior any. There's more space in the center. So we turn up the three-phase power. We see a little wobble phase, but it's unstable. And then it'll go to a flat spin quite easily at the top. As we have seen, when the hole in the center of this flywheel gets much larger than the rod, we get flat spin. But when the hole and the rod aren't two different sizes, we get just wobble. And we have to make the hole even smaller at 16 millimeters, 8 millimeter rod, and we expect to see just wobble if that's true. Let's turn it on. It wobbles and goes up, but it never goes to flat spin. Finally, I will summarize on paper what we have learned. We've made 6 different flywheels with different hole sizes and numbers of magnets. Here's 8 magnets and 16 in the middle of the hole, 4 magnets, 20 millimeter hole, 8 magnets, 20 millimeter hole, 4 magnets, 25 millimeter hole, 8 magnets, 25 millimeter hole, 30 magnets, 4 millimeter hole. And we've tested all of these, how they spin on these 2 sets of 3-phase coils, which are staggered. They both spin clockwise and they're out of phase by 60 degrees like that. And we can have different hole sizes and different rods. So you can see the results tabulated here. Basically, whenever the hole size is fairly close to that of the rod, we get a wobble motion. Whenever the hole size is much larger than the rod, we get flat spin. The best cases are here at 25 millimeters, where a 12 millimeter rod gives you a nice transition between wobble and flat spin. Perfect geometry. If we make the rod bigger, 16 millimeters, we only get wobble. If we make the rod smaller, 10 millimeters, we get flat spin. It's a quite small area. Some of them just give flat spin and wobble if we haven't adjusted it properly. So these general principles may be very interested when we concern UFO propulsion. We have to measure the forces of the transition upward when it goes from wobble to flat spin and see whether that relates to UFO propulsion. Thank you to the stars. Let's watch it one more time. This is low frequency, a wobble. 8 hertz. 10 hertz, it rises up and hits the plate. 12 hertz. And then at 13 hertz, it turns completely flat, like a spinning top at its apex. Hertz, just like the spinning top when it's risen up. Slow it down again. 13 hertz, 12 hertz, 10 hertz. It wobbles again like a top as it falls. Speed it up again. The top when it's fully erect. Slow it down again, 10 hertz, 9 hertz. It's like a wobbling top. To summarize, our best model for getting a transition between wobble and flat spin uses a 25mm hole in the center of this 80mm flywheel, which has 8 magnets, and a 12mm aluminium rod. We turn on the power. First it wobbles, 10 hertz, and then it rises up at about 12 hertz, and then it turns into a flat spin. Slow it down a little, and it wobbles, 12 hertz. Speed it up again, turns into a flat spin at 15 hertz. As we turn the power up further, 20 hertz. It can go quite a way up before friction against the upper surface knocks it down. When we flip that magnetic flywheel with 25mm hole the other way on a 12mm rod, it behaves exactly the same way. First it wobbles at about 10 hertz, then it rises up, turns to a flat spin at 15 hertz. As we go up to 20 hertz, it's still there, and then it falls due to friction with the rod above.
I walked a little closer. I wanted to really see what it was, but it was moving. And instinct told me to back up, so I backed up to stand about at least 15 feet away from him. And I thought, well, that's kind of odd. It's going the opposite way. It's going counterclockwise. It's not going clockwise. It's going counterclockwise. Grass was moving one way and the machine was going the other way. Well, let's say a round circle like this, and there was round deals like this all the way around. There were portholes actually, and when you look underneath them, there was more than 4. Because when I looked at from the side of it, it looked like there was 4, but there's more. There's I can't remember now. Is it 6 or 7? Was a pile of them anyway, but they all turned. All you could see was like when they got higher up, it was like a vapor. Like you see behind a jet plane, vapor, but you couldn't see it that clear. It was more like a fog, you know, it was thinner.